Hello to everyone. Join with me to study this topic in integral calculus. This is integration by parts. So I have two numbers for integration of by parts. So I have integral y squared times e to the 2y dy, and then number 2 is integral of y times cosine for y dy. So note that integration by parts, we use this formula uv minus integral v du. Okay? So this will be the solution for number 1. Okay? So since this is integration by parts, so I will let u will be y squared. Then differentiating both sides du, this will be 2y dy. And then dv. dv is e to the 2y dy. And then integrating both sides, so this will be v is equals to 1 over 2 e to the 2y. Okay? So uv minus integral v du. So u is 1 u is y squared, Then v is circle brackets 1 over 2 e to the 2y. Then minus integral v, this will be 1 over 2 e to the 2y. Then du is equal to circle brackets 2y dy. Okay? So I have here 1 over 2 y squared e to the 2y. Then minus, I will place the constant before the integration symbol. So this will be 1 over 2. And then this will be 2. Then integral of e to the 2y times y dy. Okay? So this will be crossed out. So I have now 1 over 2 y squared e to the 2y minus integral of e to the 2y times y dy. Again, this is integration by parts. So u will be y, and then du will be differentiating y, that will be dy, and then dv is e to the 2y dy, integrating both sides, so this will be 1 over 2 e to the 2y. Okay, so I've just copied this one. So this will be 1 over 2 y squared e to the 2y, then minus. So I will apply integration by parts. So this will be circle brackets. The formula is uv minus integral v du. Okay? So this will be 1 over 2 y squared e to the 2y, then minus uv. So just use square brackets. uv, u is y, and then v is circle brackets 1 over 2 e to the 2y. Okay? And then minus integral of v 1 over 2 e to the 2y, du is dy. Close. Okay? So this will be 1 over 2 y squared e to the 2y. Then I will place constant outside, because this is constant, so outside of the circle brackets or square brackets. So this will be 1 over 2 y e to the 2y. Then this is negative, right? Then negative to negative, that will be positive. So this will be 1 over 2. Then just place outside 1 over 2. So this will be integral of e to the 2y dy. So let u will be 2y. Then du will be 2 dy. Dividing by 2 both sides. Cross out 2. So I have now du over 2 is equals to dy. Okay? So, this will be 1 over 2 y squared e to the 2y minus 1 over 2 y e to the 2y plus. Okay, I'll just transfer this one. So, u is 2y and then du will be 2 dy. Divide 2, cross out. So, I have now du over 2 is equals to dy. I will erase because there is no solution. Okay? So, plus 1 over 2. Then, integral of e to the u. dy is du over 2. du over 2. So, this will be equal to 1 over 2 y squared e to the 2y minus 1 over 2 y e to the 2y. Then, plus 1 over 2. I will place outside of the integration. So, this will be 1 over 2 also. Then, integral of eu du. So, this will be 1 over 2 y squared e to the 2y minus 1 over 2y e to the 2y plus 1 half times 1 half, that will be 1/4. So, eu, so this will be eu. Take note, integral of eu du is equals to eu plus c. So, this will be eu plus c. Okay, so I will erase in here for my final answer. So, this will be 1 over 2 y squared. This will be e to the 2y minus 1 over 2 y e to the 2y, then plus 1 over 4 e to the 2y. U is 2y, so this will be 2y, and then this will be plus c. Then I will factor out. So this will be 1 over 2. Then this will be e to the 2y. Then circle brackets. This will be y squared. Then minus 1 over 2. So this will be y. Then this will be plus 1 over 2, then plus c. Okay, let us check. 1 over 2 times e to the 2y times y squared, that will be 1 half y squared e to the 2y. And then this will be minus 1 half e to the 2y times y, that will be 1 half y e to the 2y. And then this one, 1 half e to the 2y times 1 half. 1 times 1 is 1, 2 times 2 is 4. So this will be 1/4 e to the 2y plus c. So this is now my number 1 answer. Okay? So I will proceed to number 2 solution. Okay, allow me to erase this one for solution number 2. Okay, solution number 2. So I have integral of y cosine for y dy. So this is integration by parts. So this will be u will be y, and then du is dy. Then dv. dv is cosine for y dy. So integrate both sides. So this will be 1 over 4 derivative of, integral of cosine, that will be positive sine for y. Okay? So formula will be uv minus integral v du. uv, y, v is circle brackets 1/4. Then sine for y minus integral v du. v is 1/4. Sine for y. Then du is dy. Then this will be 1 over 4 y sine for y. Then this will be minus. 1/4 will be placed outside before integration because this is constant. So this is 1/4 integral of sine 4y dy. Okay? So I'll just write in here. So equal to 1/4 y sine 4y minus 1/4 sine, integral sine 4y dy. Okay, so u will be 4y. du is 4y dy. Divide 4 both sides. 4 will be crossed out. So I have now du over 4 is equals to dy. So this will be 1/4y sine 4y minus 1/4. Then integral sine u is 4y. Then dy is du over 4. So this will be 1/4 y sine 4y. Since this is constant, so I will place also outside. So this will be times 1/4 integral of sine u du. Okay? So this will be 1/4 y sine 4y. Then this will be 1 times 1, that's 1. 4 times 4 is 16. Then integral of sine u. Take note, integral of sine u du is equals to negative cosine u plus c. So this will be negative cosine u plus c. So this will be 1/4y sine 4y minus minus. That will be positive. 1/16 cosine u plus c. Okay? What's the value of u? Allow me to, this is 1. So 1/4 y sine, okay, I'll just put 1/4 y sine 4y, then plus 1/16 cosine u is 4y in here, 4y, and then plus c. Then common factor will be 1/4. 1/4, circle brackets y sine 4y, then plus 1/4 cosine 4y, close, and then this will be plus c. So let us check. 1/4 times y sine 4y, that will be 1/4 y sine y. Then 1/4 times 1/4, 1/16 cosine 4y. This is my number 2 answer. Since I'm done with number 2 and number 1 and number 2, I think that's all. Friendly reminder, if you have questions regarding to my discussion, you may write your comments at the comment section. Then, if you agree with me, please like and share, and do not forget to subscribe to my YouTube channel, Franz Maths TV. Thanks for watching.